Hello friends, today we will learn shear force and bending moment for simply supported beam. So here we have taken one example on simply supported beam. A simply supported beam of span 4 meter carries 2 point loads 5 kN and 7 kN at 1.5 meter and 3.5 meter from the left hand support respectively. Draw SFD and BMD showing important values. So first of all, we draw a figure with point loads. So this is simply supported beam, two supports at point A and B. So reaction exerted at point A RA and at point B is RB. Now this total span is 4 meter. So distance between two supports is 4 meter. Now 2 point loads 5 kN and 7 kN at 1.5 meter and 3.5 meter from the left hand side. So left hand side here 1.5 meter, 5 kilometer, and from left hand side 3.5 meter 7. So here 3.5 meter. Force is active. Now this remaining distance is 0.5. This in between distance is 2 meter. Okay. Now first of all we will calculate RA and RB by using equilibrium conditions. So we have three conditions: sigma m at point A equal to 0, sigma Fy equal to 0, and sigma Fx equal to 0. Now this third condition is not useful for this example because there are no horizontal forces. So we will use these two equilibrium conditions only. So first sigma Fy equal to 0. So sigma Fy equal to 0. So summation of all vertical components on all vertical forces equal to 0. So this RARB acting in upward directions and 5 kN and 7 kN acting in the downward direction. So we will take here upward is positive and downward is negative. Otherwise upward on left side and downward on right side. So here RA plus RB minus 5 minus 7 is equal to 0. Therefore RA plus RB minus 12 is equal to 0. Therefore RA plus RB equal to 12. This is our first equation from first condition. Now use second condition, sigma m at point A equal to 0. Take moment of all forces at point A. So we will start from B point. So RB. Now first mention the sign convention. Here anti-clockwise is positive and clockwise is negative. So this RB in anti-clockwise direction towards A, so it is positive. So RB into perpendicular distance, that is 4. Now second force 7 kN, it acting clockwise, so minus 7 into perpendicular distance, and that is 3.5. Now third one, it also acts in an clockwise direction, so it is minus 5 into perpendicular distance, that is 1.5 is equal to 0. Now by calculating we will get 4RB minus 24.5 minus 7.5 is equal to 0. Therefore 4RB minus 32 is equal to 0. So we will get RB equal to 8 kilonewton. 8 kilonewton. Now put this value in first equation, that is RA plus RB is equal to 12. Therefore RA plus 8 is equal to 12. So RA equal to 12 minus 8 is 4 kilonewton and this is 8 kilonewton. So RARB, now put here RA is 4 kilonewton and RB is 8 kilonewton. Here we have calculated reactions RA and RB. Now next calculation is for SF, shear force calculation. Shear force calculation. So second step is shear force, that is SF calculation. And here we will draw SFD and BMD. Take projections for drawing the SFD and BMD. Now we will take a section at each point. Now this A, B, point C and D. Now SF at point B, when we take section just left side of B, and that is equal to just right of B, that is 0, and SF at point B just left of B, so that means here. So this section at left side of B and calculate the shear force. So there is only one force acting in upward direction. So here on section right side, if it is downward then positive, upward is negative. So section right side downward is positive, section left side upward is negative. Okay, so here this upward force, that is minus RB is 8, so minus 8 kilonewton. Similarly, we will take section just right side of D. So SFDR is equal to, so same one force acting in upward direction, that is minus 8 kilonewton. Now take this section just left to D and calculate SF. So DL equal to, now there are two forces, one is upward and second one is downward. So minus 8 plus 7, that is minus 1 kilonewton. Now similarly take section just right of C, SF CR, similar, minus 1 kilonewton. Now shift this section just left of C, SFCL equal to, now this 5 kilonewton also in downward direction. So minus 8 plus 7 plus 5 is equal to 4 kilonewton. Now shift this section just right of A and calculate SF AR, that is equal to 4 kilonewton, and SF AL. So we get minus 8 plus 7 plus 5. Now this are in upward direction, so minus 4, that is equal to 0. Now by using this shear force, we can draw shear force diagram. So this is neutral axis, A, C, D, B. So at A point, the value is 0. So mention this 0 point. Then 4 kN. So mark 4 kN. Mark 4 kN and draw a vertical line 0 to 4 kN. Then at C point 4 kN. So mark 4 kN. So this is horizontal line. Now when it is simply supported with point load, we will draw straight lines, vertical or horizontal. Now at C left side -1. So this is -1. Then at D -1. So again horizontal line -1 kN. Then -8 upward direction. So downward -8. So -8 kN. At B point also it is -8. So for left side shear force, we draw a horizontal line, and for right, we move in a upward or downward direction. So right is 0. Now draw this vertical line up to B point. So this is our SFD, shear force diagram. This is positive and this portion is negative. So it is our SFD. Now our next step is calculation for bending moment. Calculation for bending moment. BM calculations. Now sign conventions. Section right side, if it is acting anti-clockwise, then it is positive. And section right side, if it is acting clockwise, then it is negative. So the sign convention we will use for the calculation of bending moment. Now start from P point. So at moment at point B, it is always 0. Moment at point B is 0 and moment at point A is also 0. Okay. Now moment at point D, take only right side. So at D point, this RB acts in a anti-clockwise. So 8 into perpendicular distance, that is 0.5. So moment is 4 kilonewton meter. Now moment at point C equal to, now this 8 into perpendicular distance, that is 2 plus 0.5, that is 2.5. Then this 7 kilonewton acting in a clockwise direction. So clockwise is negative. So minus 7 into 2. So moment So 8 into 2.5, that is 20, minus 14, and that is 6 kilonewton meter. Here make moment at A point equal to 0. If we calculate 8 into this total distance is 4 minus 7 into 3.5 minus 5 into 1.5 will get answer 0. So this is 32. So here 8 into 4, 32, minus 7 into 3.5, minus 24.5 and minus 7.5, that is 0. So moment at point B is 0 and moment at point A is 0. So you can calculate this directly. Now draw BMD, bending moment diagram. So draw a reference line, neutral line, A, C, D and B. Now moment at A is 0, moment at B is 0, moment at C point is 6. So mark here 6 kilonewton meter. Now in SF we have drawn a straight lines, vertical or horizontal. Here in BM we will draw an inclined line. So from 0 to 6 it is inclined line, slant line. Then at D it is 4. So mark 4 kilometer. So it is also slant line, 4 kilometer. And at B is 0. So this bending moment is in a positive portion. So bending moment is positive. So in this way we can calculate this SF and bending moments and draw SFD and BMD in a simple manner. So for next video on shear force and bending moment for cantilever beam, you can visit our channel. Thank you.